Good day. Welcome to this next lesson. In this lesson, we'll be going through an exam question on rates of reaction. The apparatus below is used to investigate the effect of a certain factor on the rate of reaction of calcium carbonate powder and calcium carbonate chunks with diluted hydrochloric acid. Okay, so if you read this, you've got calcium carbonate powder and calcium carbonate chunks, and it says that they are using it to investigate the effect of a certain factor on the rate of the reaction. But look here, here's powder and here's chunks. So which factor are they looking at? They're looking at surface area, right? So we immediately know that we're looking at an experiment with surface area. A known mass of calcium carbonate powder was added to excess diluted hydrochloric acid, and the decrease in mass of a certain time interval is recorded. Readings were taken every 30 seconds. Okay, so here is the mass of calcium carbonate powder and the decrease in mass. So after 0 seconds, there is 0 decrease. And then after, do you see after 4 seconds, there is a decrease of 2 grams and then it doesn't change. Okay. Experiment B, we have calcium carbonate chunks. Here is the decrease in mass. And again, it stops at 2 grams. Okay. So now it says formulate an investigative question for this investigation. Okay, so now what's important, grade 12, is that you guys need to realize that there's a difference between an hypothesis and an investigative question. An hypothesis will make a statement and it will refer to variables to each other, and it doesn't have to be correct. In other words, your statement doesn't have to be correct about the two variables. So in other words, in this case, an hypothesis would be an increase in surface area will decrease the reaction rate, or an increase in surface area will increase the reaction rate. Okay, it can't be the reaction rate is affected by a change in surface area. You need to relate two variables and state how you think they're going to change. An investigative question, first of all, has to have a question mark at the end. If you do not have a question mark at the end, it is not an investigative question, and they're going to mark it wrong. I know it's ridiculous, but there you go. And then what you're doing is you are saying, how will this happen? Okay, so it would be, in this case, it would be, how does a change in the surface area affect the rate of the reaction? That's it. Okay. Now it says, write down a balanced chemical equation for the reaction between calcium carbonate and dilute hydrochloric acid. Okay, so what they're looking for is the fact that you should know that if you've got calcium carbonate plus an acid, okay, what do you form? You should know that if you've got an acid and a base, you always form a salt and water. If you've got a carbonate, you form the salt, the water, and carbon dioxide. And remember what we said about the salt. The salt is not table salt. It's not that. It is an ionic compound which, when dissolved in water, well, forms ions, okay? So it's going to be calcium chloride plus carbon dioxide plus water. And how do I know it's calcium chloride? Well, if you think about it, look here. We know that we're forming carbon dioxide, right? We know we're forming water. So there's my carbons and oxygens used up, okay? Admittedly, I've got 2 hydrogens, so we need to fix that. That's going to be horrible, but no, we'll worry about that in a minute. And what's left is the calciums and the chlorine. So it has to be calcium chloride. Calcium, chlorine is got... Okay, it's CO3 2 minus, yeah, that's right. Carbonate is CO3 2 minus, therefore calcium is 2. Also, calcium is in group 2, so therefore you know it's got a ionic charge of 2 plus, okay? So now let's have a look at balancing this thing. So do you agree we've got 2 hydrogens here, so we need to put a 2 here. And let me just erase that because it's a horrible 2 and write it again. And let's see now. So now we've got 1 calcium, 1 calcium, 1 carbon, 1 carbon, 3 oxygens, 2 hydrogen, and 2 chlorines. Yay, it wasn't horrible at all. Yay, yay, yay. Easy peasy. Now it says, using the tables above, draw 2 graphs on the graph sheet comparing the decrease in mass versus time. Okay, so we didn't actually get any graph paper, so we're going to draw it but looking at the decrease in mass. Please note we're looking at the decrease in mass. So we're going from 0 to 2. Okay, so we're going from 0 to 2 versus time. Okay, so do you agree that we're just going to break this up into, we'll make this 1 and we'll make that 2, just to make it easy. So the first one we're going to do is we're just going to look at this first one, and we're going to say, okay, when time is 0, obviously it's 0. And we're going to break it up into 7 bits, so it becomes 1, 2, 3, 4, 5, 6, and 7. Okay, what are we going to do? We now need to plot these points. So when x is 0, y is 0, because this is going to be decrease in mass, in grams. Okay, and I'll do the black one. I'll do this one in black, the first reaction, and I'll do the second one in a different color. So when x is 1, y is 0,9. When x is 2, y is 1,6. When x is 3, y is 1,9. And then from then on, it is 2 and it stays across. So it goes, and that's supposed to be just parallel. Okay, right. I apologize for bad drawing. Okay, so that is this one. Now let's look at the next one. When x is, now this is calcium carbonate chunks, okay? When x is 0, y is 0. When x is 1, y is 0.5. When x is 2, y is 1. When x is 3, y is 1.4. When x is 4, y is 1.7. When x is 5, y is 1.9, and then it goes off. So do you see what's going on here? Okay, so now we've drawn them, okay, and obviously this is B and the black one is A. Okay, now it says which reaction reaches completion first? Well, it's obviously A. A, the black one, reaches completion first because it reaches at 2. It reaches there at 2 first, and then it just stays there. Then it says, how does the loss in mass compare after the completion of both reactions? Do you agree that the loss of mass is the same? Yeah, it is 2, and here it is 2. So they are the same. And why are they the same? Because they had the same amount of calcium carbonate in, okay? And how do we know that? Because it says that this is, yeah, a known mass of calcium carbonate powder was added, okay? And the point is that the procedure was then repeated some using chunks of calcium carbonate, and it's got excess dilute hydrochloric acid. So there's more than enough hydrochloric acid. So what is being used up is the calcium carbonate. And then finally it says, what conclusion can be drawn from this investigation? Well, the conclusion that can be drawn is an increase in the surface area will increase the rate of reaction. There you go. How easy was that? Hey, not too difficult. You just need to go through things step by step.